Ladies and gentlemen, please welcome our next speakers Nigel Douglas and Thomas Labarussias, presenting the topic, Remediate Cloud-Native Threats in Real-Time with Talon.
Okay, we're good to go. So thank you everyone for attending. I don't think you hear any sound, that's just me. So yeah, thank you for attending. We're going to show a new designed solution we put together, and it's called Falco Talon. So can we just start off firstly, can people put a hands up if they've heard of Falco? Or, okay, there's a few people at least who've heard of the technology. That's good. So to start off, I'm a developer advocate at Sysdig, and Sysdig's the kind of core company behind the Falco project. But Falco is an open source technology that we'll come to in a second ago, but in a while. But yeah, basically we contribute to this project and as well as other projects. Again, you can contact me directly. But Thomas, do you want to introduce yourself?
Yes, I'm Thomas Labarussias in French. I'm also senior developer advocate at Sysdig. Before that, I was SRE for almost 10 years. I did 5 years of on-call, so I know what it is to manage a production. I'm also CNCF ambassador for 9 months now, Falco contributor, and I'm also the original creator of some tools we introduced to you after in the slides. And you can reach me on classic networks.
Cool. So yeah, today's talk is going to be around runtime security. So you might be wondering what we mean by runtime, and that's specifically after you build your application and you deploy and it actually runs in the likes of Kubernetes, serverless, it's actively in progress, it's running. So that actual containerized workload that's actually present, that is what we're looking to secure in this case. So anything from the procedures, the processes, and the tools used to secure that is what we're talking about when we mention runtime security. That's going to be a recurring theme. So yeah, Falco, for the people who haven't heard of the project already, it's a CNCF graduate project. So again, for quite some time now, for several years, it was an incubation project. And what that meant was Sysdig donated the project to the Cloud Native Computing Foundation. It was there that it went through rigorous trials and tests to prove that it was a compliant tool that organizations can, actually run in production environments. There's a due diligence process as part of the CNCF graduation flow, and that involves third-party auditing, so on, just to make sure that the application, the tool itself that you put into production, again, meets all those rigorous requirements. So yeah, moving on. This is the part. So we've graduated this year, and this is a fantastic milestone for the project. It means we can happily tell users that this is, the best in class for what it does. So you might be asking, well, what does it do? So we're going to the next slide. At its core fundamental, Falco handles system calls. So what a system call is if you think of the Linux kernel, like the brain of your machine under the operating system layer, anytime you create a file, you delete something, a network connection is invoked, that creates a system call. So if we run a program within the kernel, we can monitor, we have observability as to all the activity, whether it be process, network, I/O activity within the kernel. And this deep visibility is the basis for understanding what is happening on the host, what's happening in the container, and even deeper, what's happening in the process that run within those containers. We'll move on to the next slide there. Now, there's two ways of looking at how Falco works. We talked about the kernel module there a second ago, which is just this probe that runs inside your kernel. But not everyone wants to use a kernel probe. There's considerations here, like what happens if that probe was faulty? Could it crash my kernel? Yes, in theory it could. And that's a scary process or possibility. So then eBBF, it's this new project that came along, and what it allows us to do is have another alternative option, which is to run it as an eBBF probe. Again, runs within the kernel, but it's similar to kind of virtual machine logic. So it's contained, it can't crash the kernel. It's running separate to the kernel. But again, we get that same deep visibility. So for things like security, monitoring, whatever it is on a host system, containers, Kubernetes, we can do that with our eBBF probe. So moving quickly on to the next slide. This is what Falco looks like. So you know, it's similar to DevOps practices that everyone's familiar with, is writing everything in YAML. So here we have a rule, and the rule has an arbitrary name, and that name is terminal shell into container. It's just, you know, text. It doesn't really do anything. The description, again, same lines as what we mentioned there in the rule name, is it's the description of what this rule will do. And sometimes you can have lengthy descriptions, and sometimes in this case it's quite straightforward. It's just telling you it's going to shell a spawn on a container. Now, the condition is where Falco differentiates from other technologies. You can have something that looks pretty simple. It's saying spawn process and, or, you know, the Boolean logic, and you're saying container and shell process. Now, these things that are blue, they can be macros or lists, but in this case, they're all macros. So what I mean by that is, if we just go back there a second, you can have this complex business logic. Like, for instance, if I was defining a macro to look for shelled processes, then I want to define what those processes are. And for instance, it's going to be based on a certain system call. So it could be event type, whatever, or it could be process type or process name, whatever the conditions you can define within those macros. The idea here is you manage the macros and the rule stays consistent. It's the same logic you expect. Another thing that's really cool about basing it on system calls is when you look on the output, we can then say, you know, arbitrary string, which is a statement like a shell respond, and then in those brackets we define the metadata, what we're actually extracting from the system call. Now you can customize this yourself. It's open source. You have free control. You can do whatever you want with it. And we'll just jump to that now in a second. So you can see here the logic. So, you know, with a list, it could be something like shell binaries, and it could be a list of binary names. Or if you're doing it based on C2 servers, then it could be a list of IP addresses. So these are some things that are subject to change, and they can be managed in whatever way you want to do it. Or you can just leave them static if you want. But the idea here is there's complex logic, which is brilliant because you need complex logic to identify security incidents, whether it be something like mutating binaries, privilege escalation, whatever it is, data exfiltration. These are all brilliant use cases, but with system calls, we can monitor effectively anything on a system, which is really cool. And out of the box, we have like 60 plus rules that are already there, so you can already test the product and understand value. And this is what you expect to see. So the idea is the more metadata fields we're going to put into it or into our output, the more we see of the output. And that's really important. We don't want to just be alerted that terminal shell existed. We also want to know all the surrounding context. We want to know, for instance, what was the container ID? That's subject to change regularly. So maybe I want Kubernetes context extracted in that output. So I might want to say, tell me what namespace it's running in. What's the pod name? What was the deployment associated with it? And further, what was the command line execution at the time of that operation? So for instance, what did the actual attacker, the adversary, run in the terminal? So you can get all this surrounding context, and the time to resolution is much quicker. So this is a fantastic use case for just showing raw output of a detection. So moving on. This is a high-level view of the architecture of Falco today, and it will come to further use case in a second. But we talked about system calls, and system calls, whether you use the eBBF probe or use the kernel module, the kmod, that's how you handle all the context from a system itself. But let's say you want to correlate context against other sources. Like a perfect example is I have a EKS cluster, Amazon Elastic Kubernetes service. Now I have a pod and I can monitor all this with system calls. I also have a Kubernetes audit service, which provides audit logs associated with just Kubernetes, the orchestration there. And I can use plugin architecture, which again, open source, you can build your own plugins. But this handles the audit service of Kubernetes, take that event data and then enrich it, correlate it against the system calls. Similarly, I could handle CloudTrail through these gRPC plugins, stream that data to Falco, and if, for instance, I have a process running in a container in a Kubernetes cluster in a cloud provider, I can correlate that context in an output, and that's really powerful. You know, if you're in a security team, you don't want to know a pod did something. You want to know which region, on which cloud account, but also in which Kubernetes cluster, which namespace. Have as much context around the attack. So that's the event collection part of it, between plugins and system calls. Then it's streamed to Falco, where it has this rule logic that we briefly touched on. and that's how you detect the insecure behavior. As I mentioned, incredibly customizable, and it's deep in its logic. So it means you can, build fairly complex use cases. Now, traditionally speaking, out of the box of Falco, it's simply a detection engine. It's detecting insecure behavior. It's not actually doing anything on that. It's just telling you, it's sort of like an audit, there's insecure behavior. So you can then use these out of the box options of stream it to syslog, so it can go to a SIM, or you can send a HTTP webhook somewhere else. So you've got these different alert options, but they're not that interesting. They're really just to alert you, to notify you that something's happened, or it might be for an audit use case. So we'll move on to the next slide. Then we introduced Falco Sidekick. So this is a pet project of Tomas, and it got introduced into the Falco project as a whole. And what this allows us to do is two things. Falco Sidekick has the UI element, and we'll touch on that in a while, which is a visualization layer for all of the output data. We said it's so rich, it's so detailed, but if you don't have like a UI, you're just looking in the terminal of all this output, so that can be a bit messy. But the other very useful element of Falco Sidekick is integrating with the actual ecosystem that you have. So if you have, like, for instance, queuing services, chat tools, like everyone's using Slack, so you're deciding, okay, I want to be notified in chatbot that an incident happened that's insecure, then detected through Falco. Or you might want to put it to PagerDuty or whatever for some kind of automation. So you have all these options, and Falco Sidekick is the notification layer. It's the kind of thing that decides, it does all that complex, annoying part of integrating with all of your system tools. And again, at this point, we're closer to 70 integrations. So if you're looking for dedicated integration, you can get onto us. We probably already have it. So this is what the visualization layer looks like. And again, it's just to make life easier. So imagine you have all these events, and depending on the complexity of your organization, you could have event stream data coming from cloud audit logs, from GitHub. They could be coming from Okta, Identity. Again, we've got plugins for all of these kind of use cases. So you're streaming all that data. It's nice to have a centralized place where you can toggle, you can search for rules based in time periods, based on priorities, and so on, which is a really cool use case. And again, that historical histogram of showing you where there might have been an unusual spike in unusual suspicious activity is really valuable. So moving on quickly is where we're at today. So we talked about Falco, reiterating what we mentioned earlier. It's the detection engine. It handles all that support source data. It then builds rules on it. There's even new features such as Falco CTL, which is a dedicated CLI tool for managing the complexity of rules in production, which again, we're trying to make the tool as easy for users as possible. Then we alert through a HTTP webhook to Falco Sidekick, which then can make actions such as demonstrating all the events within a visualization UI. You can port forward or load balance to a certain IP, or you can then stream the events to a third-party source. And that takes us up to the reaction side of it. Do you want to take it from here, Tama, or?
Like you prefer.
Yeah, I'll just close off on this one. So we mentioned there wasn't a response feature in Falco, and this was frustrating for community because they say, look, if I detect a crypto miner as an example, it's all well and good, but like I need to stop it. And if it's the weekend or something, it's kind of useless. So I need something that will kill that miner or do other activities. Again, you want automation, but you also want to take action. So that takes us to the next slide of how we did it with Falco Sidekick. That was, generally speaking, a little bit complex in the sense of you had to understand functions as service type options. You send it to a service where it decides, okay, I'm going to run a script in the cloud provider or whatever. But this is all kind of automation reactions. It's not interacting with the primitives of Kubernetes. And that takes us to your part.
So basically, even if you are interested by integrating these outputs, these function as a service, serverless systems with Sidekick and Falco, we created a series of blog posts on falco.org. They explain how to integrate Falco with Lambda, Knative, Argo Workflow, Tecton, so you will have example anyway. So developing its own response engine has some benefits for sure. Total flexibility, because basically you are the developer, so you manage your function by your own, you develop whatever you need, so you have full control over the actions. You don't depend on a third party, you don't depend to a SaaS platform, except for the cloud provider running the function. And you can also use procedures and services you may already have in your company. If you are already familiar with Lambda, you should already have the CI and the CD to deploy Lambda. Your developer may already be familiar with how to develop with serverless SAM also. These frameworks, how to develop a Lambda function with these frameworks. But in every benefit comes with a drawback of some drawbacks. You need to develop by your own the actions, to manage the errors, the authentications, the logs, the notifications. If you ever tried to develop something for Kubernetes, to call the control plane API, it's not so obvious, especially for beginners. You have to manage so many complexity. Managing the dependencies with the Kubernetes SDK is not really easy. It may require to install and manage new services, new CI workflows, new CD workflows. If you don't already use a function as a service system, you may have latencies, especially with Lambda, because it uses cold start. So you have to wait your Lambda to spawn and then start. And if you want to chain actions, basically do that and then do that and do that, it's not so easy to do so, especially if you are not really familiar with queuing system to manage the communications between one function to another. So we decided to develop a project called Falco Talon. Talon for humans and for birds is that part. So basically Talon is for kicking asses. This is the main idea for marketing. So we created a tailor-made response engine for Falco. The idea behind was to provide to the community someone out of the box. You don't have to write any line of code to specify your reactions. It's pretty convenient. Basically, Falco Talon will receive the alerts from Falco directly or from Falco Psychic, your choose. And with rules, in the same way that Falco does a correlation between a syscall event and an alert, Talon will do a correlation between a Falco event and a reaction. A reaction means several actions to perform. And these actions basically can use out of the box on catalog what we call actioners. So right now we have 10 out of the box actioners. You can terminate a pod, labelize a pod, create a network policy, execute a command, run a script, get the logs. This one is pretty interesting because you can get the logs of your pods just before terminate it. You can delete a service account, a user, a deployment, a daemon set, everything that is not a pod, cordon a node. The drain actioner is a work in progress right now. We have Calico, Cilium will come in maybe at the end of this month or June. And we also have Lambda function, like we have also in Psychic, but with more parameters. Everything is managed by YAML rules files, so it's quite easy to extend. We can override anything, and you can manage that in a GitOps manner. That's the purpose. The actions can be triggered based on the priority of the event, the tags, the source, the Falco rule name, and what we call the output fields. Output fields are all the elements that have been collected by Falco to create the rules, and what we had that in the output section of the rule files for Falco, of the rules for Falco. Basically, it's all elements which are dependent of the context, the pod name, pod namespace, pod labels, container ID, container name, and so on. So you can, for example, create rules to terminate a pod only except if this pod belongs to the namespace kube system, for example. Which the actions can be sequential. We also have a deduplication of the alerts. From time to time, Falco can trigger the same alert twice or 3 times. So we'll not try to terminate the same pod 3 times. It's better to deduplicate these events. We also have out-of-the-box identifiers. So you can notify your teams by Slack, email, webhook, collect the logs in Loki, Elasticsearch to create nice dashboards after. We know my managers love dashboards. And we also have Kubernetes events. So it's easy for everyone to get access to what Talon did We don't want to have a black box. We want to be sure everyone will be aware of what has been done by Talon and when. And the logs are structured to have trace ID. Especially will integrate soon traces. So you will have traces directly made by Talon to have the reception of the event, the correlation between the rule and the action, all actions that have been triggered, the results of all actions, and the notifications at the end. And we also provide Prometheus metrics because it's a standard now. So this is an example of a Talon rule. Basically, we have a rule with a name, like we have in Falco. We try to keep the same spirit between Falco and Falco Talon to don't lose people. So we have a match session. The match session is in charge to do the correlation between the Falco event and the actions. So in that situation, if Talon receives an event concerning the Falco rule named right below etc, and this rule doesn't concern the namespace called kube system, then these actions will be triggered and then will be performed. The first one is open the file with the actioner script. The script is just over there, so we just echo the content of the file with the shell, with a sh as shell. You can change that for bash, fish if you are a moron and use fish in production. And the second action is to terminate the pod, but we ignore the daemon sets, we ignore the stateful sets, and if we don't have enough healthy replicas, we avoid to terminate that pod. I was SRE for 10 years, like I said, so I prefer to keep my production alive and just notify my team something strange is happening, take a look manually, and I don't want an automatic remediation that could break my production and impact my end users. We don't want that. You can see we have a block on the right called action. Basically, you can create a block action and reuse it like we can reuse macros in Falco rule. And of course, you can override the parameters at every level. It's basically, it's easy. So you don't have to write the same action for every rule. If you have a terminate action, you can just create one and reuse it from one rule to another.
Yeah, and we can't emphasize enough when you match more than one action to a Falco rule. Like, this is, you could say, a unique approach now when we're talking about cloud native security. Because, like, let's say if you had a tool and you said, we're going to terminate a workload, but then you lose the logging context on the pod. So maybe, for instance, if you want to take an action to say, like you can see here, you define your parameters and you say a grace period in seconds, you can then have a rule that would say something on the lines of, let's say, do some forensics, whatever the check is, give us the surrounding data, ship that somewhere, and then have a second action on the same rule that says terminate the workload after 8 seconds if you want. That way you can actually have the flexibility to ensure that you do get the surrounding context collected from it, but you also get to mitigate the risk. So I think that's pretty amazing.
Yeah, right now we are preparing, it's a work in progress on your side, but we are writing a blog post to explain if something bad is happening in your pod, we could collect the logs of the pod, then we cordon the node, then we drain the node, and then we terminate the node at the Amazon level by just calling the Amazon API, stop that EC2. So this is the main idea. So the situation right now with the whole ecosystem, we have the syscall collections with eBPF. We collect any events, that possible events with the plugins. For example, I don't have that right now in my demo, but I developed a plugin to collect all Bitcoin transactions. So basically, the idea was to demonstrate we can collect any kind of event with Falco and trigger alerts. And so I have triggers when one suspicious wallet receive or sent money, Bitcoin. Just because they try to scam me, so I got their wallet ID and I'm tracking them to be sure no one else will be impacted. Before I had a Twitter plugin, so we'll see the interface after, but it's not possible anymore because we have to pay to get access to Twitter API. But before, people were able to tweet in real time and with a specific hashtag, and all tweets were coming in the background in the UI in real time. So we have Falco for the detection, Falco Cyclic for the notification. A good thing also with Cyclic, Nigel didn't mention that, but with Cyclic you can do a small routing system. So for example, you can send all your events to Elasticsearch for analytics, for statistics, and you can send the alerts to PagerDuty, Opgenie, Alert Manager, Grafana on call, only if the events has a priority above critical, for example. So you can filter a little bit and avoid to wake up your SREs or DevSecOps, whatever the name, too often. And we have Talon at the end to react. So we'll try the demo. Cross the finger, sorry. So I have a running AKS cluster in that situation. I have 3 nodes. So because I have 3 nodes and Falco is deployed as a daemon set, because it has to be connected to the kernel, and right now kernels are not distributed, so we need 1 Falco instance per node. This is why I have this one, and this one. We have Falco Cyclic UI. This Redis pod is a data storage backend for Cyclic UI, and we also have Talon. I will not show the Falco rules because the file is pretty big, but in that situation we have this one. This is the Falco Talon rule set. Basically, I created actions that can be reused from one rule to another. So this action is to terminate a pod. This one is to create a Calico network policy to block outbound connections. This one is to labelize a pod. So it will have the label suspicious equals true. This other one is to add the label spawn equals true, and it will remove the suspicious label. And the rule is there. If Talon receives an event concerning the Falco rules terminal shell in a container, basically the rule we had in the slide before, and this event doesn't concern kube system of Falco, then we'll have the label suspicious. If a package manager is started inside a container or inside a pod, and once again this pod doesn't belong to kube system or Falco namespaces, we'll labelize the pod as spawned and we move suspicious. If we write something under /etc, we'll get the content of the file. If we connect to suspicious IP, that could be a crypto miner, server, or control center for a botnet, we'll first create the Calico network policy to block all future network connection, outbound connection, and then we'll terminate the pod with a grace period of 0 seconds. Terminate the pod. This is basically the idea. So
and it's a really good, like, just while you're setting that up, you know, when you're doing it as an API approach, like Kubernetes was designed for automation. So like you want to automate based on those existing primitives. And that's, I think, where this project is different. You know, we're not telling users to stop using network policy. Instead, we'll block network traffic. We're instead saying define network policy if you want, and then based on suspicious action, we can labelize it, which would enforce the network policy. Either way, we connect to the existing Kubernetes primitives that were already defined long before this project, and that's the way I think security should be done when it comes to cloud native. But you know, you'll see it in a second.
So I have this running pod. Consider it as your beloved application. It can be whatever. For example, WordPress with so many CVs. You can take a look at the labels. We only have app and pod template hash. So I will just exec to get a bash shell into that pod. So we have access to that pod. We are in the pod, and if you take a look at the labels, now we should have suspicious. If I take a look on the Falco Talon logs, we have the event So this is the event received by Talon. The match between Talon between the event and the actions to perform, the actions itself, labelized pod as suspicious. We also have the status, everything is notified. No, it's not success. Something there, status success, and then the notification. If we take a look at the Kubernetes event, in the default namespace, we have all details there also. With the status, the message, the rule concern, so the Falco rule that has been triggered, the action, the actioner, label, the event received by Talon, the namespace, and the pod, the output of the actioner. Everything is there. Let's continue. Now if I take a look once again to the pod, the suspicious label disappeared, but we have pwned instead. Everything has been done by Talon in the same manner, in real time. So I will write now something under /etc, server-wise. Something like that. Any word, banana?
Yeah, it should be fine.
So I wrote something under /etc, and if I take a look once again on Talon, so we have the Kubernetes, this action has been performed, Kubernetes script, and we have the content there. So if we take a look at the events once again, script is there. We have the content also there. We have just an ls to be sure the file is there, etc banana, and we have the content. So if someone is putting a script inside your pod and runs it, you will have the content. It's pretty common. And the last thing to show is I will call my own domain, and I will take a look on this on the right corner, right bottom corner. So I will call my own domain. You see, in less than 1 millisecond, the pod has been terminated. And we also have the creation of a Calico network policy.
So two things are happening, like the termination ensures the workload
That
was
will
thrown down,
exactly.
yeah, and the threat's mitigated. But in the scenario where, for instance, it wasn't an instant termination, well, network policy anyway blocked the outbound connection. So even if you wanted to make that connection, it was already isolated by network policy.
Exactly. If I try the same process, if I go to the new pod created by the deployment and I try to curl my own personal domain, once again, it will just fail. And all these events, we can find them, okay, like forward crashes, in the UI. So we have everything that has been done, the first terminal shell, the first apt command, the second apt command. This has been done by apt. The installation of curl, the write of hacked by supervisor has been hacked in the file descriptor in the etc banana file. The curl to my domain, the suspicious outbound connection. Everything is detected by Falco, and you can find them out in the UI in few milliseconds. Of course, you have, like Nigel said, you have pie charts, you have histogram. You can filter on almost anything. For example, if I want just critical, everything is filtered.
Yeah, and the context tagging is so important.
Exactly.
It's one thing mitigating, isolating risk, but in a real cybersecurity scenario where you for instance, have to generate a report and prove, does this match CIS practices or NIS2, HIPAA, PCI DSS, whatever it is. Having the labels matching those controls means, yeah, sure, we detected and we prevented the threat, but now you can actually generate for your manager a report showing, look, we've met those controls. And this is powerful for pen testing, but actually for compliance in the end. So
The demo worked. Not so bad. I think we have been a little bit...
we did it very quick.
Way.
I guess at this point, there's a few questions that have come in. How does Falco compare to other SIMs? I mean, starting off with that, first of all, it's not a SIM. I think the biggest obvious difference is with a SIM, you have applications or whatever, programs, machines, and they ship their logs to a backend, and that backend then you perform forensics or kind of alerting based on it. But with this, we're not actually handling the log data. We're not storing it. Like, what we're doing is we stream. It's a streaming approach. So we stream the event through Falco, and then Falco does rule matching on the live stream. So that's how we see things in real time. It's all system calls as they happen, but we don't hold those logs. Yeah, that's the major difference. We aren't a SIM. The other thing that's really cool about that streaming approach and what we talked about there earlier with the data enrichment is, you know, most SIMs don't do it. So they handle logs from different sporadic sources, and then it's just stored in this tool, which is great and all. But by streaming and then doing data enrichment on the streamed events, you can do a correlation against different sources like Kubernetes or Cloud Audit Log. I don't know if there's anything else you want to mention on that.
I'm not sure to get all the questions, to be honest, because I see what a SIM
Yeah.
is, but the link with Google Workspace is not common. But the thing is true, if you are able to write a plugin to collect events from the Google Workspace,
Yeah.
you can correlate suspicious threats from different sources in the same tool. The idea behind the plugins was to have the same syntax to write rules, whatever the source is. So with the syscalls, you can protect your host, your containers, your VM. With the Kubernetes Audit Logs plugin, you can protect your Kubernetes control plane. With the CloudTrail, or for GCP, I don't remember the name for GCP, but you can protect the cloud account level. You have GitHub Webhook, a GitHub Webhook plugin to protect your Git repositories, for example, whatever. We also have plugin for Okta. You know, Okta has been breached several times in the last month, so we created a plugin to detect the exact thing that happened to Okta. MFA fatigue, basically.
The next question's about in-memory detection. I guess what you're talking about is fileless malware. The answer is yes. We have rules based on like memfd activity. So yeah, you can absolutely detect in-memory, which is actually, again, another strong use case for eBBF and kernel level visibility, because if you're looking at the user land, you won't be able to see in-memory activity. But if it's in the kernel space, yes, you can. Where Talon is running, where is it running? How can it be executed? Action Kubernetes service account. Do you want to answer that one?
Yeah, sure. The easiest way to install Talon is through an M chart in the Kubernetes clusters. So it will use the service account and also the IAM role. If you are using EKS, you can do a mapping between service account and IAM role. But technically, you can run Falco anywhere. If you want it to react and to call the Kubernetes control plane, either you use the service account, either you can give it a kubeconfig file like we do on our laptops. Both can work. It's not an issue.
The last one, oh yeah, sorry, there's two questions there. Is there packet capture functionality? That was my thing. So I wrote a blog about that yesterday. So the way I approached it is, say, for instance, T-Shark, which is headless Wireshark. If you had that running, for instance, in a dedicated pod, and you had a Talon action, which is to reach out to Kubernetes API and run a shell script, well, that shell script could run T-Shark. So the use case here was, you know, I would terminate a workload, but after 10 seconds. And in that 10-second period, I'm running a Wireshark capture, which gave me the 10 seconds of packet capture around that security incident, which is pretty cool.
We are working on that for sure.
it's surprisingly stable, but the question is there, yeah, like, is there any delay? And I guess there is latency. It's always really about how far away from the source it is. Like, this was your point about...
Yeah, basically we trigger a capture, but technically the event already happened. This is a big difference between Falco, the open source project, and what our company does above that with the commercial project. They have a solution to start a capture before.
5 seconds prior.
5
yeah.
seconds before or something like that. It's totally different. It's not on the Falco side. Just to mention that Warrior Shark has been created by Loris De Giovanni. Loris De Giovanni is our boss. He's also the creator of Falco. So he knows a little bit about what it is to do packet capture.
Yeah, is there an easy way to forward detections to a SIM? I guess that's your point around Falco Psychic.
Exactly. This is the main purpose of Falco Psychic. We have integrations, of course, with Elasticsearch, but you can forward the logs to Loki.
Yeah, Splunk, any of them really. I think Splunk has...
If one integration is missing, you can just create an issue, and we can see to integrate that. In the next upcoming release, at the end of July, we have Dynatrace, Sumo Logic, for example, Minayo. I don't remember all of them.
Yeah, but the point is, to answer, is it an easy way? It's simple, really. Like, you know, Falco's doing all the hard, heavy lifting, and then you just pick the dedicated endpoint. I guess there's a bit of authentication required, but other than that, that's it. Can't make it simpler than that. Yeah, your storage, like retention on Falco Sidekick. You can
unlimited retention right now. You can specify a TTL for the event. By default, the TTL is 0. It means in Redis we keep the information forever. And if you want to be sure to have a long-term storage, thanks to Redis, you can have a flush of data on disk. So if you mount to PVC, a volume, directly in your pod, you will have unlimited retention.
We don't
have that right now.
Yeah, like we have a histogram that'll show the historical activity, and that's a little bit of end user interpretation of, okay, well, there was no activity yesterday, now there's a spike today. Why is that? But that's not like a feature.
They became much bigger than I expected, to be honest. I created that something like 4 years ago because I needed something nicer to show in my demos. Before I only have the terminal to display. It wasn't really sexy for people. So I created the first version of the UI. People liked it, so it became a more advanced project, and people liked it more, so it became bigger and bigger. I cried a lot of blood because of JavaScript for that. My advice is not to use that in production for long term. Use that out of the box when you install Falco to have an overview of what is happening in your cluster right now. Use it to tune your rules, and when you are confident enough about what you implemented for Falco, use a real SIM like Elasticsearch, Dynatrace, Sumo Logic, Loki, whatever, for long-term retention and to have better dashboards, more control. It's just a debugging tool. It's not really made for big productions.
I'm conscious we're probably on our last minute, is that right? It's just, this is really a closure slide. We mentioned a lot of abstract logic there, like things between the packet capture example or network policy. And sometimes users maybe just want to come back and read it. So we put 2 QR codes there, one to our Sysdig blog, but one to the Falco project blog. And they're both around Talon response actions, but it's like, if you're more interested in isolating network behavior and you want to do something around that with Talon, then that's an interesting blog. But the Sysdig ones, yeah, about the T-Shark example. So I don't know, they're fun starting points. And yeah, that's it. If you want to contact us, we have some details here. But other than that, hope the session was useful.
If you want the slides, just reach us, and everything is open source. You can use them. Everything. All slides, all blue-colored words have a direct link to the element, so you will not have to search on Google after.